Hello guys, welcome to another tutorial brought to you by Programmium. Guys, this is 16th video for our Java playlist, and in this tutorial we will be creating some Java applications that can check if a number is a prime number. So without any further delay, let's get started and open our IntelliJ IDE. So guys, now you can see that I have opened my IntelliJ IDE, and this is the file that we have created and modified in our previous video. So let us quickly create our Java file by the name of prime numbers. So let us put our main method and put our comment here. For those who don't know what are prime numbers, let us see some theoretical stuff here. These are numbers that are only divisible by 1 and the number itself. So prime numbers are those numbers that can be only divided by 1 and that number itself, excluding 1 and 0. And remember, 1 and 0 are not the prime numbers. So let us create a logic that can calculate or check if that number is prime or not. So first thing first, let us create a scanner object again by the name of input new scanner system.in and create an integer by the name of iterator and a number. So let us out the user, enter a number, and number is equals to input dot next int. So now we will creating a for loop here, but before that let us put a if condition. And let me tell you why I am putting an if condition here, that we want to check if that number is prime number or not. But first we will see that if that number is equals to 1 or 0, and if that number is equals to 0, or if that number is equals to 1, then we will just say the user these are not prime numbers. Fine. Okay, then we will put an else here, and in this else, where we have now seen that the number would not be equals to 0 and 1, we will put a for loop here and use our iterator, and let us initialize it with 1, and after that we will run this loop until that iterator becomes equals to number, and then increments its value. So here we are again making another variable by the name of you can say that increment. So and also initialize it to value 0. So now here we will first see that if that number modulo operator and then iterator is equals to 0, then just increment value here. So let me first define this, why we are using here this condition and then this condition. Let us see here. So you have an idea what does this condition do? In else we use a for loop that just takes the increment value, takes the iterator value 1, and it will run until it reaches the value of equals to that number, and after that we incremented its value. So after that we used here if condition, and we put a condition that if that number modulo operator and then that iterator, this here iterator, is equals to 0. What does this mean, guys? This means, let me show you here in this command. So if we divide for modulo operator 2, then its result would be 0. You know why? Because if we divide 4 by 2, then its result is 2, but the remainder is 0. That means here if the remainder is 0, that means number is perfectly divisible by 2. So we will use this logic here that if the number divided by the iterator gives us remainder 0, then that means that number is perfectly divisible by that number or iterator. So here we use this, you can say this condition here, because number, for example, if we use here 4, then the iterator will first check from 1, and if 4 divided by 4 modulo operator 1 returns 0, then it just increments this operator here. And also we are using here if increment is equals to 0, then we will use here break and shout here number is a prime number. Fine. And else here we will shout number is not a prime number. Fine. So if this condition is achieved, then the compiler of course have to do these stuffs, but if not, then we put a stuff here else here and just continue here. So that because we don't want our loop to exit, we just want this condition to exit. So now let us see that if our program is working fine or not. Oh, the program didn't. So we have to use here Control Shift F10. So enter a number. I am entering here 7. 7 is not a prime number and 7 is a prime number. So let us see what's happening here. Actually 7 is a prime number. So let us see here. So guys, I am here in a web application that just calculates its if a number is prime or not. Let us use here 447 and calculate here. 447 is not a prime number. So our program is showing some faulty results and we have to debug that application. So let us open IntelliJ IDE and check what's happening right now. So let us remove these if else from here. We will come here and check if that increment is equals to 2, then that means number is prime. and sorry, number is prime. Else we will say south number is not prime. So let us run it again. Enter a number. I am entering here 447 again, and 447 is not a prime number. So again I am running it, and this time I'm entering here 8987 this, and it is also not a prime number. But let us see in our calculator. So I am entering here this, and let us say that this is not a prime number. So guys, I hope so that our application is running fine, but let us again see that how this application is working. So let me close it and just show you why we use this logic here. So you have an idea how this works. Let's skip this and come to this else here, and sorry, for loop here. Actually we want our number to be divisible by every number until that number is achieved. So in simple words, if we put here 7, then that we want that number 7 to be divisible by every other number up to that number 7, so that we can check if that number is a prime or not. So for that we have used here for loop, and we used an iterator one for division here, and you can say that 1 goes to number 7 here. So 7 divisible by first 1 here, and the result would be 0 here. So iterator increment here is 0, and its value is incremented by 1, so now it is 1 here. So that means we got one divisor here. And as you know that prime numbers, or in simple words, those numbers can only be divisible by two numbers, 1 and the number itself. So our first condition is met, and that condition was that number should have to be divisible by 1. So after that, again it runs loop here, and go the iterator here becomes 2, and number which is here 7 divided by 2 is not gives us 0 remainder. Its remainder would be 2 remainder. This operator is not running right now, and after that this continuous statement works. That simply do again run this loop here. So if that number becomes 7 here, then 7 divided by 7 is equals to 0, and this time the increment operator here would also work, and the previous increment value was 1 here, and this time would become 2 here. So we just use a condition here outside loop. Let me just collapse this loop here, and we use here that if increment is equals to 2, that means the number is prime, but if not, then that means the number is not a prime. So we have created our prime number checker Java application. We can further modify this. So guys, to achieve our goals, what we have to do here, we will create a scanner object, and after that system.in. After that we will create some variables like range, number, iterator. After that, so what now, let us out the user, enter number up to which you want prime numbers, and now let us store this input in our range variable. So now what we have to do here, we will just so let us initialize this variable, and it will have to go until it becomes equals to that range, and after that iterator plus plus. So after that, let us create another for loop here, and what we have to do, let us create some other variables here, like increment is equals to 0 and inner iterator. Fine. So let us use inner iterator from 1, and after that inner iterator should have to go until it becomes equals to that iterator, and now inner iterator plus plus. Fine. Now what we have to do, we will repeat the same procedure as we write here to check if that number is, if iterator ampersand sign, sorry, percentage sign, inner iterator is equals to 0, then what you have to do, you have to increment it, and after that we will use an if statement here. And what does this if do? If increment is equals to 2, then just out iterator is a prime number. So let us check our program. So enter number, I am using here 100 and nothing happened. So guys, now we got some errors. So guys, I'm again running it and checking it if it is again showing. Yes, it is again showing some logical errors here, but as I think our logic is absolutely correct here. What we have to do, if that number remainder is equals to 0, then just increment it, and if the increment value is equals to 2, then what, so that iterator is a prime number. Let us put an else statement here, and what we have to do. So guys, there is some flaws in our you can say that application in this loop here, as we have already seen that 0 and 1 are not prime numbers. So we don't have to start iterator from 2, we have to start it from 1. So let us check it. Now I'm entering here 100. Now 2 is a prime number, but what happened here, as we saw SAR2 here, that means our program is working, but there are some other bugs. Let us see how to resolve those bugs. So this loop becomes true, and execution comes to this loop. Now what happened, as 1 is smaller than 2, it enters here and it checks first 2 divided by 2 modulo 1 is true, and it increments value of the increment. First here was 0 and now it increments to 1, so now it becomes 1. Again it inner iterator is incremented by value 1, so now 2 is equals to 2. Again this condition is checked, now this value becomes 2 here, increment value becomes 2 here. Okay, increment value becomes 2 here. Fine. So what happened, now this code of block is executed because increment value is equals to 2. So we got 2 as a prime number, as 2 is a prime number. So what's next, our iterator value here is incremented by 1, so it becomes 3 here. And what happened here, as 1 is smaller than 3, this condition is checked, and also here what happened, increment value remains true here, keep in mind. So now what happened here, this condition is checked and 3 when divisible by 1 got 0 as a remainder. So again this value is incremented, so it becomes 3 here. So that's the flow here that we only saw here too. So what we have to do here, we have to use increment is equals to 0. Why? Because if this condition is true, then executes this, and if don't, then what you have to do, you have to reinitialize the increment to value 0. Let me run it again, show you the results here. Let us enter 100. So now we got our results. Now you can see that these numbers are actually prime numbers. Let us make fun of this program and we will use here 200, and now you will see that every number mentioned here are prime numbers. So guys, now you can see that our program is working fine. Let us see how these loops work here. So first we take range from the user, and after that as we know that 0 and 1 are not prime numbers, so we exclude these two from our range and start it from 2, and our loop will go up to this range here. And after that we initialize an variable for the purpose of division here, and it should have to be initialized from 0, sorry, from 1, and 1 would have to go up to this iterator is achieved. So all of the other stuffs are the same here that we mentioned above, and these are very important and conceptual and logical operations, and actually these programs are used for your logic building, and once your logic is built, then what you have to do, you just have to apply that logic and you will solve your problems. So enough for this video guys, we will be meeting in our new video. So until our next video, stay tuned and don't forget to like our videos, subscribe our channel and share with your friends. Goodbye.